Any other questions? What do I do with my chat box? There it is. All right, so let's continue, or let's start. And I'm using a electronic write pad, so it sometimes I might be messier than when I was in class. We'll see how this works. Let's change it. Okay. So on the first problem in 3.4, find the correct end behavior for the given polynomials. Okay, so we need to understand things that we've already written down. If we see a function that's an x squared, we know the graph looks like this. If we see a graph that's a negative x squared, we know the graph is a parabola, but it's upside down. X to the thirds look like this. Negative x to the thirds look like this. So it just flipped the other way there. This is true. This is true for all 2 powers, 4 powers, 6 powers, even powers. These two are true for all even powers. If you put a negative in front of it, then it's the same thing. It looks very similar, maybe a little different. And this is true for all odd powers. 3, 5, 7, 9 odd powers. So it says find the correct end behavior. When we talk about the end behavior, we're talking about the tips. These are the ends. So we only look at the highest power when we're discussing end behaviors. We only look at the highest power. So this is the highest power. It has a negative. This is a negative x to the 3. Negative x to the 3, the end behavior looks like this. Do you see? If we look at this one right here, the ends, the left side is up. The right side of this graph is down. And that's what a negative x3 looks like. That's what a negative x5 looks like. It doesn't matter about the number in front. It just the number in front, makes it skinnier or fatter. That x to the third, a negative, the left side is higher than the right, and the right side is going down. If it was a positive, the right side, you see, the right side would be going up, and the left side would be going down. So it just wants to know what the end behavior is, and this is actually questions on the homework and on the test. And you would just have to pick that. They would have something like this. A is arrow, arrow. B is arrow, arrow. C is arrow, arrow. D is arrow, arrow. And so the correct answer for this problem would be D. The left side is up and the right side is down. The left side is up and the right side is down. And that's the type of questions there would be on here. So the next one, the highest power, the next one, I'm trying to get my pen to work. Sometimes it has a mind of its own. The next highest power is x to the 6, and it's a positive in front. It's a positive 7. So x to the 6 is the same thing as x squared. They're both going up, the left side and the right side. It's some kind of a parabola. When it has an x to the 6 power, sometimes it does different shapes, like it might look like this. But it's still both, the end behavior is for an even power, that both are going up and there's a positive in front of it. The end behavior is both ends are going up. And that's what they're asking here. What is the correct end behavior? All right. Just chime in if you have any questions. I can't really read the chat box, so if you have, you just turn on your microphone and just yell at me if you have anything. Or I'm just going to ramble on forever. All right, let's move on. Graph this function using the X and Y intercepts and the end behavior. Factor first if the expression is not factored. So it is factored already. So this expression is factored. So we have to know, and we can just say this 2x squared. Well, I'm going to try to save some space. We can just say this function equals 0. So that means in this place, there are three things multiplied together. 2x squared has to equal 0, or x plus 2 has to equal 0, or x plus 1 has to equal 0. So this is finding the X-intercepts. Remember, finding the X-intercepts is when you set each of these equal to 0. We also call them zeros, finding the X-intercept for the zeros. If I divide by 2, I get x squared equals 0, and take the square root of both sides, I get x equals 0. That's one of the X-intercepts. My next X-intercept, get 2 to the other side by subtracting 2. There's an X-intercept at -2. And finally, take this 1 to the other side by subtracting 1, and I get x equals -1. That's my other, oh, this is going to be crowded. That's my other, see, these are the three X-intercepts. We found those. Now we have to find the Y-intercept. Y-intercept, see, X-intercept is when make y equal to 0. So, but now we have to find the the X-intercept is when make y equal to 0. So we did that already. Y-intercept is when we make x equal to 0. So now I'm going to find the Y-intercept. And I'm going to make all x's equal to 0 in the problem. And so here's 2x squared times x plus 2 times x plus 1. And I want to make all the x's equal to 0. So if I put a 0 here, 0, and a 0 here, 0 plus 1 is 1. 0 plus 2 is 2. What's 2 times 0? Uh-oh. Did I make you talk?
0.
Yeah, there we go. 0. So do you see these are all multiplied together, and the answer is 0. 0 times anything is 0. So our Y-intercept is at 0, 0. When x is 0, y, this equals y. Y also equals 0. So this is an X-intercept and a Y-intercept. So we've graphed that. So, and for this, it's going to be multiple choice. That's all we really have to do. And then the last thing we need to know is the end behavior for this graph. And that's going to be kind of important here. This graph is actually, we have to multiply all the x's together when you look at that. If you multiply all the x's together, I'm not worried about all the other stuff multiplied together, but if we multiply all the x's together, we get x to the 4th. Do you see? X squared times x squared times x is to the 1 power is x to the 3. And then x3, or I can do x squared times x times x. These are 1 powers. I get x to the 4th. When you multiply numbers with the same base, you add their powers. So this function is really an x to the 4th function. It's important to understand that. because when you multiply all those x's, you have x to the fourth function. So the end behavior for a positive, this is a positive x to the fourth function, the end behavior is a parabola. Remember, x to the fourth function, end behavior is a parabola. That means the graph is going up on the left and it's going up on the right. So from here, I can actually choose the correct graph to draw. Watch what happens. Okay, there's still more I have to teach you. I'm running out of room. I'm going to change my color so I can look at this. I'm going to change it to dark blue. Okay, so we need to also understand this. If I have an x and it has a second power, that means the graph bounces. Bounces off this X-intercept. If I just have an x to the 1 or 3 to an odd power, then it goes through the graph goes through the X-intercept. So if we look here, I'm going to erase some of this. If we look through here, and this is only when it's in factored form, the graph is x squared. The graph, any even power, the graph bounces on that X-intercept. This one is going to go through because it has there's a 1 power on the outside. There's no power on the outside. It's odd. So it's going to go through. So watch what happens here. On the X-intercept at x, remember this one gave us 0. This one gave us that one. So we know it's going to bounce. And this one is going to go through. You're right? At a -2 and -1, it's going to go through. So our graph looks like this. It's going to approach it and bounce off of it. It's going to go up, and then at some point it's going to go back down and going to go through. Then it's going to go down somewhere, I don't know where, but it's going to go back up and it's going to go through this one. And then it's going to go off and up. So you can tell, we have to find those X-intercepts, and then we have to figure out, are they going to bounce or go through? It's going to go bounce off of that one because it's an x squared. This is a power of 1, so it goes through. This is a power of 1, so it goes through. So we're drawing this where we know it's got to bounce, so that means it's going up. And it has to turn because it has to go back through this one. It's going to go through it, and at some point it has to turn because it has to go through this one. Now, the only thing we don't know is when you're doing the homework, I'm not sure how you're going to do the homework on this. I think that's all you're going to have to do. But if there's still something we don't know, how high and how low do those endpoints go? Right? How high do those two spots go? Everything else we know, the graph is going to go towards that dot, it's going to bounce off. The only thing we don't know is how high, where. What if it went up to here and then turned around, or down to here and then turned around? Those are the only two things we don't know.
Hello.
Yes.
Oh, my microphone works? Oh, yes. Okay. Sorry to interrupt.
No, that's fine. Oh, who's here?
It was Michael.
Oh, you okay? Hi, Crystal. I didn't see you come in. Can you hear me, Crystal? Turn your.
Hello.
All right. Great to have you. All right. Anybody? Did you have a question, Michael, or are you just checking your microphone?
Just checking my microphone, sir. Thank you.
That's fine. That's fine. All right. So yeah, we're gonna get through this. All right, so how do we find out how high those two spots go? Well, I'm going to do just a little bit more erasing. And if we look at these spots on the graph, the x value right here is -1/2. So if we plug in -1/2 into this function, it will tell us how high the graph, it'll tell us what the y value is. Oh, by the way, there's a 2 in front of there, and then we have to square this. So we have to put that into our calculator. Oh, no. 2 parentheses -1/2, and then I'm going to square it. Then there's another parentheses, -1/2 plus 2, close parentheses. I'm going to put another parentheses, -1/2 plus 1, close the parentheses, hit enter. And if I want it in fraction form, when I put this into my calculator, I get a +3/8. So if you look at this graph, uh-oh, I erased a lot. This graph goes here, bounces, and goes up to 3/8 and then goes down. You see, this is 1/2, so it's a little less than that. So it bounces off of here, goes to 3/8 and then goes down. Now we have to figure out how low it will go here, and we have to put a negative between -1 and -2 is -1 1/2. -1 1/2. The correct another way of writing -1 1/2 is -3/2. So we had to put -3/2 in here, and let me do that. Oh, -3 divided by 2 squared, parentheses. By the way, -1/2, you could just put -1.5 plus 2, close parentheses, and -1.5 plus 1. And I get, and if I put it in fraction form, I get -9/8, or I get -1 1/8. So it goes down to -1 1/8. Then it goes back. Wait, oh, it goes up here. Let me erase. So it goes down to -1 1/8. Then it goes back up and off. So this spot right here is -1 1/8. So that's what the graph looks like. On the test, you won't have to find those points because you'll be able to pick the correct answer. I mean, you could, if they had 2 of these, then you just look at those endpoints and see how high they go. Not the endpoints, but you would look at these spots to see how high they go. You'd put a test point in there. But most of these tests are, you pick, is this the answer? Is this the answer? Is this graph the answer? Or is this graph the answer? So, I mean, this is the closest one to resemble the one we were trying to draw. So that would be the answer. So that would be the kind of test question we had. The homework's going to be a little bit more difficult. They actually want you to put the dots. They want you to put these dots in here, and then they're going to ask you what the endpoints are. Since this is an x4, when you multiply it, the endpoints are going to be up and up. And then it's going to kind of like construct this graph for you. All right, let's try another one. That was a tough one, especially because of the amount of paper, the amount of room I have. I think I went up way too fast. I don't know where I'm at now. Give me a second. All right, so we are on this problem. So we're going to try this one again. Let's look at what the end behavior is first. This is x times x is x2. And if you look here, this is x3. Do you see this is x? There's an x here, and then there's an x3 here, x minus 1 to the third power. So when you multiply those together, you get x5. So a positive x5 has an end behavior. You should hopefully you wrote those down. That looks like this. The right side is up. The left side is down. So we know our graph is going to look like this. The right side is up and the left side is down. The x-intercepts, we have x, x plus 2, and x minus 1 to the third equals 0. So here you can say x equals 0. That's one x-intercept. X plus 2 equals 0. Take the 2 to the other side, and x equals -2. That's another intercept. And here we're just looking at the inside. X minus 1 equals 0. Take the 1 to the other side by adding 1. Adding 1. And I get x equals 1. That's my other intercept. So these are my three intercepts. This is an odd intercept, so the graph goes through it. This is an odd power of 1 here. The graph goes through it. And this is odd. The graph is going to go through it. So the graph's going to go through all of these. We're going to go through this. And you see it has to go through this one. So halfway, you start turning up and go through it. Halfway between 0 and 2 is 1. So you're going to turn and go through it. And then you're going to go down. So that's pretty much all you really have to know. And then I'm going to keep on going. But the only thing we don't know is how high these points are. And I'm not sure about the homework, but for the test, that's not too important. I mean, to find out how high it goes, once again, you plug here to find out how high it goes between 0 and -2 at -1. You plug -1 in here. -1 minus 1 is -2. -2 to the third power is -8. -1 plus 2 is 1. And then we multiply this by -1. When you multiply all this together, negative times a negative is a positive. It goes up to 8. So this graph actually goes up to 8 and then back down. Sorry. If you had to do that, I'm not sure you're going to have to do that. Maybe for the homework, it goes back down here and then it goes down. And then you would do the same thing for this one. I'm not going to actually do it for this one, but you would do the same thing. You'd plug in this one halfway between these two intercepts is positive 1/2. And you'd plug in 1/2 to each of these and find the answer, and that would tell you how low it goes. I mean, that's it. You find the x-intercepts, you find the endpoint behavior, you draw that endpoint behavior, you draw the x-intercepts, and then you just have to decide, are you going through it? And all three of these we're going through because they all have a power of 1 or 3. They're all odd powers. So odd powers means they're going to go through it, they're going to go through it, and they're going to go through it. If it was an even power, it would bounce off of it. All right, so let me try the next one. I don't want to try this one. So remember what the problem said up here, and I'm going to go back up. Let's read this one. It says, graph the polynomial using the x and y intercepts and end behavior. So just the x and y intercepts and the end behavior, factor each expression. Well, both of these expressions were factored for us. Number 5 is not factored for us, so we have to factor number 5. And if you look, can anybody tell me what method I would use to factor this one, number 5? How many terms are there? There are 4 terms, so we have to use the 4-term method to factor. Remember 4-term method? Parentheses around the first 2, parentheses around the second 2. I have this tool in the way. Hang on. And make sure there's a plus sign between them. And x squared factors out of here. When I divide both of these by x squared, I bet you thought you weren't going to have to factor anymore. I get x plus 6. Those cancel. Here, a negative 4. Do you see when the third term's negative, you have to factor out a negative. So a negative 4 divides into both of these. A negative 4 factors out of these. And when I divide negative 4 divided by negative 4, I get a positive 1x. Negative 24 divided by a negative 4 is a positive 6. This works out great because the parentheses have to be identical. Then we're going to factor out the parentheses. Oh, Lord. So we get an x plus 6 that factors out. And then we're left with x squared minus 4. Okay, so we factored it, except we're not done. This is 2 terms. You have to recognize that we're factoring 2 terms here with this x squared minus 4. So you have to factor this all the way. This is something squared minus something squared. Put an x here and a 2 here. So this factors 2 terms, x, 2, 2, 1 plus, 1 minus. So does everybody see how I factor that? First I factor the 4 terms, and then I had to recognize, wow, I can still factor this. That's 2 terms, and it's the difference of squares that factors to this. So our zeros are x plus 6 equals 0. Take the 6 to the other side, and I get negative 6. Here, x plus 2 equals 0. Take the 2 to the other side, and I get x equals negative 2. And here, I get x minus 2 equals 0. Take the 2 to the other side, I get x2. Those are my 3 zeros. The end behavior is an x3. The end behavior, the right side, a positive x3, the right side's up and the left side is down. And look at these. You have to look at the factored form. They all have a power of 1. There's no power attached to each of those zeros, so they all go through. Since they're all odd, power of 1, they all go through. So from the right, we're going to go down through this. Halfway between 2 and negative 2 is 0. So I know at some point halfway between, it's going to come back up and go through. Halfway between negative 2 and negative 6 is negative 4. Somewhere on the x negative 4, it's going to turn around and go back down, and then it's going to look like this. So that's the graph. It says graph the x-intercepts and the endpoints, and we did it. If they want you, don't forget, you have to plug negative 4 into the original problem. It'll tell you how high it goes. Or you can plug, in this case here, this is x0. Plug 0 into the original problem. And I'm going to actually do that because that's easy. If you plug 0 into the original problem, 0, 0, 0, you see that turns to 0, 0, 0, and it goes down to negative 24. So this graph will go down to negative 24, then back up. So you can graph it more precisely on how high and how low. If you plug negative 4 into the original problem, it'll tell you how high it goes also. Just know the end behaviors that we went over, and then how to find those X-intercepts, and you should be okay. On the test, I don't think I'm going to have you, figure out how low or high it goes. All you have to do is find a graph that has a similar shape. Everybody okay? Somebody say, oh yeah. Are you guys there?
Yes.
Yes, we're here.
All right. It's a lot different than in the classroom because I don't get much response. Everybody's sitting there, probably eating breakfast. Let's see. Probably watching TV, playing their Xbox. All right, so here we go. I'm going to do this. Number 6. Anybody know how many problems there are in this section? So I don't have to scroll down again. I only have 2 minutes now. I have 25 minutes. So find a polynomial of this function. Let's look at these. Let's look at so we're working opposite of backwards of what we just did. So I have one of the zeros at negative 3. So x plus 3 is a 0, right? If I say one of the zeros is x is negative 3. Hang on, my pen's not writing. To get the negative 3 to the other side, I add 3, and I get x plus 3 equals 0. Do you see? That's why I get an x plus 3 here. I also have another 0 at 1, a positive 1. So that means this would be x minus 1. For me to take it to the other side, then that would be a positive 1. And then I have a 0 at 4. So this would be x minus 4. So there's my equation to start us off with all the zeros. If you look at them, x, 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 they all have one. I mean, I have a 1 power because the endpoints is up, right, down, left. That's an x to the 3. That's an odd endpoint. So if you look, I have x times x times x. I have x to the 3. So I have everything I need. I'm done with this equation. I've actually finished it. I don't want you to multiply or anything. I've actually finished it. Except there's one more thing you have to do. We don't know what the coefficient in front of it is. So there's always going to be an a sitting in front of it. I just want you to know there'll always be a coefficient. It could be 1. If it's 1, you won't see it because it's 1. But there's always a number sitting in front of this. The way we find out what a equals is by using our Y-intercept. We plug 0 into x, and our answer should be, this is our y, by the way, then our answer should be 6. Y should be 6 when I plug 0 in. So watch what I do. I'm gonna write everything down here. I'm gonna bring it all down. A times 0 plus x times 0 minus 1 times 0 minus 4 equals 6. You see, this is where that y comes in. The y equals 6. If x is 0, y is 6. X is 0, Y is 6. All right, so let's just do the math. 0 plus 3 is 3. 0 minus 1 is -1, and 0 minus 4 is -4. A equals, what's 3 times -1 times -4? When I put that in my calculator, I get 3 times -1 times -4. I get a positive 12. A times 12 equals 6. Take the 12 to the other side. It's multiplying, so we're going to divide by 12. And A equals 6 over 12 reduced to 1/2. So this A equals 1/2. The answer to this question is 1/2 x plus 3, x minus 1, x minus 4 equals the function, equals y, f of x. And you can put the f of x in front, it doesn't matter. I think they want you to put it in front. That's a -1 and an x minus 4. So we just find the zeros, then we have to find A. And I'm hoping we have another one to do there. So this one's really not too bad. There are some tricky ones here in the homework. So if we look at the zeros, can somebody tell me what the zeros are? The X-intercepts. These are the X-intercepts. Those are the first things we write down. X-intercepts are x equals -2 and x equals 1. The way we write those is x equals a +2. We write them with the, x equals a +2. We write the other signs because to get the 2 to the other side with the x, you have to add 2 to both sides. And a 1 is an x minus 1 equals y, or we can say equals 0, equals y or f of x. So that's our equation. We're just about done. The only thing we have to do now is find A. And the way we find A is we use this point. All x's are 0, and the y turns into 6. So A equals all x's turn to 0, and the y becomes 6. So this 0 plus 2 is 2. 0 minus 1 is -1. 2 times -1 is A times -2. This is A times. In order to get the -2 to the other side, it's multiplying times the A, so I have to divide by -2. Divide by -2, and A equals -3. 6 divided by -2 is a -3. So my equation then, this A becomes -3. -3 x plus 2 x minus 1 equals the function. Now be careful. Did you notice that this goes through it and this goes through it? That means these have to be a power of 1, and they are. Look at the endpoints. The endpoints are both down. That's a -x² endpoint. And sure enough, we have an x², x times x, and we have a negative in front. Do you see? So this just proves and helps reiterate that, hey, we did our equation correctly. Our endpoints are both pointing down, which means the coefficient in front has to be negative. All righty. Moving on. Okay, this might be the hardest one. How many more do we have? 8. This is the last one. Yes, this is the last one. Okay, so we're on number 8. The zeros are here and here. X equals -1 is a 0, and x equals 1. To write those down, the -1, we change it to a +1. The +1 changes to a -1. It equals the function y or f of x, whatever you want to call it. Now, this is really, really important. This is really important here. We haven't seen this yet, and you're going to have to do this. And there's at least one on the homework that is you might need some tutoring help. I wouldn't worry about it. This would be the hardest problem, but there's harder ones on the homework. Don't sweat it, because those really super hard ones won't be on the test. I mean, there could be something similar to this on the test. So the only thing we have to do now is find A, but there's still more. Look at this graph. Here's the endpoints. We know by looking at those endpoints, we know this is an x² graph negative because the endpoints are down. They're both down. We know that's a -x² graph. So we know A is going to be negative when we do our calculate A. Do you see? By looking at the endpoints, I know A is going to be negative. But there's something else that we have to change. Watch what happens. If I go from here and I'm going to the point, does it, I'm all over the place. Does this graph go through or does it bounce? As I'm approaching it, do you see? It does not go through. It bounces off that point. This bounces off. And then the other x-intercept, it bounces off. Remember, bouncing off are even powers. So these x-intercepts have to have a 2 on them, a 4 on them, a 6 on them, something like that. It has to have a power of an even power. Bouncing on those x-intercepts means you have an even power. An odd power goes through. So we know that there's at least an x2. Now, it could be an x4. We're always going to go with the lowest even power or the lowest odd power if possible. So we're going to use a 2 on those. So we still have to find A now. And the way we find A is we look at the y-intercept. Everywhere there's an x, we're going to plug a 0. Everywhere there's y, we're going to plug in a -8. This changes to -8. This changes, the x changed to 0. A 0 plus 1 is 1. 1 squared is 1. -1, -1 squared is a +1, by the way. A times 1 times 1 is 1A. Another way of writing 1A is just A. So in this problem, A equals -8. So our answer is -8, x plus 1 squared, x minus 1 squared equals our function. We had to put these squares there because it bounced off. And do you see, now I have, if you look at this, I have x squared and I have an x squared. When I multiply those, I get an x4. And by the way, an x squared graph, a -x² graph looks like this. Remember, if I said a -x to the 4th, it's still the same endpoints. But because it's an x to the 4th, it does some kind of turning. It turns at least 1 less than this. So it turns 3 times, 1, 2, 3. So that's why we get this different shape. It's not a U shape. It's a U shape that turns. If we had an x6, it would turn more and then go down. So that's why we end up with these x squares, because it bounces off and we're just going to say squared to that. And that's it for the day.
Thank you.
Give me a second, and I'm trying to hit stop for recording.